Hi everyone. So in today's video we're going to discuss my multiplayer add-on version 2. We're going to revisit some of the topics I discussed in my last video. We're going to also discuss what the purpose of this add-on is and the direction of its development. So let's jump straight in. I've increased the DPI slightly to help read what's on the GUI. And I'm now in the Properties panel. And in the Properties panel for the world settings you'll see that we have this networking panel at the very bottom. Now the networking panel basically is configured for networking, and it gives you all the properties for the global networking properties. In this case, what kind of network terminal we are we a server or a client, which is selectable from this drop-down. And we also have the current tick rate, which will be the frequency at which the game is updated. The frequency at which the network is updated, which will be different to the game, and also the metric sample interval, which is basically to do with how many times, or the time delay between updating network metrics of the send rate and so on, and also the socket port, which is to do with which port the server should be binding on. Now I by convention use 1200, although typically you should use ports with an order of magnitude greater, such as 12,000 and probably even more than that. But I, by convention, have always used 1200. So once you've configured this part of the GUI, and that's basically on one blend file you'll have a server and the other blend file will be a client. You'll then have to look at the specific configuration for each network object. So if we use the logic editor, because we're actually editing the logic on an object, and I don't discard the logic bricks for now and just look at the properties window, you'll notice that we have a few new panels called network, network state, replicated attributes, templates, and RPC calls. So the network panel is quite straightforward. It's the first point of call when you're setting up network logic. By default this will be disabled, and if you do disable it you'll notice that all of those panels disappear, which means you don't get any cluttering. Now in this panel you'll also set something called a remote role. Now technically this should be greyed out if use networking is disabled, I just haven't bothered yet. But essentially, if when we enable use networking, this role will become relevant. And the purpose of the remote role is to determine whether or not an object should be sent over the network, and if it should be, what kind of authority it has to do things with function calls and attributes and so on. So we will actually explore the context of this a little bit later on. But for now, if you do want to have this object working over a network, we need to give it a role that isn't none. So in this case, let's set it to simulated proxy, and it won't really do anything for us now, but it's good practice, and enable use networking. So if we start from the top down, firstly we have these RPC calls. Now an RPC call has a number of different areas that we need to consider, but first let's describe what an RPC call basically is. In the context of this add-on, an RPC call is a message that can be sent over the network to the server or the client. Alongside this message, we can also bundle in data in the form of object properties, and these can then be set on the remote machine. So it's a message that also happens to set properties before the message itself is picked up by the logic brick sensors. So you can be sure that if you've, for example, received an RPC call that sets some position information, if you triggered a Python controller that used that position information, it would already be set on the properties for you, so you could then access that data. So in the RPC call we have a name, which we can change, and I'm going to call this example, and you'll see here that it actually changed the name field, so you can change it either way, either place. And we also have some icons here which can be clicked. There's also another icon on the left, which is an arrow. So let's look at all of these in due course. We're currently configured to be a server, so the target for this function call is a client, meaning that this is going to be sent from our machine, the server, to the client. And because of that, the arrow points away from the RPC call, indicating that it's exiting this machine. Now we're currently a server. If we set this target to be the server, then it means that the machine in question is receiving this RPC call, even though technically, as we are a server, we're going to execute this locally because we don't need to send it over the network. If we were the other way around and we were a client, then the arrow would reverse. So basically the arrow points towards the function name if the target is the same as the current network mode in the scene, or sorry, the world parameters, and it'll point away if it's different to the world parameter network mode. So one thing I will say now is you typically want to configure all of the network logic in one blend file, and then have another blend file which basically sets the network mode. That way you're not duplicating all of your assets. So that's what this arrow does. Now if we look at these reliable and simulated buttons, what is the purpose of these? Well, essentially, function calls are by default unreliable, and this means that if they are dropped by the network, i.e. the data packet that we send from our machine to the other machine doesn't get there, then by default it doesn't matter and we won't care. There are times when you do need to send a message that has to get to the other side. You should be careful here, because if you set things to reliable the entire time, then you'll choke the bandwidth out if you're not careful through redelivery messages. But sometimes you will want something to get to the other side, and you'll use the reliable flag for that. Now if you click that, you'll see that this sort of file icon, which just happens to look a little bit like what I want it to look like, this file icon becomes active, and you can disable it again here. I think that is right, yeah. Great. So, now there's also this start icon. Now this start icon is the simulated icon. Now what this means is that if this is sent from a server to a client, and the client's remote role is either simulated proxy or autonomous proxy, it will be able to execute that function. By default, if the client is a simulated proxy and you do not have simulated enabled, it will not be allowed to execute any RPC call. So there are certain RPC calls you might want to enable a client to run. On all clients, technically. We'll explain that in a minute. But not always. So what you'll do is you'll use the simulated star as necessary. Now, you can also have a client set to an authority role. What that tends to mean, or should always mean in the context of my network system, is that it's been spawned locally and it hasn't been sent over the network. If you send something over the network and it has a local role on a client as an authority, something's gone very wrong. Because what happens is, the remote role we set here is the remote role on the client, and the local role on the server is always authority. So what happens is, to explain a little bit further, if the network object is defined in the context of the server, and it has a local role of authority and a remote role of simulated proxy, when we send this to when we replicate or copy this object over the network to clients, their local role will be set to the remote role that we set on the server, and their remote role will be set to the role we set on the server, which is the local role. So to explain, basically the local role and the remote role on the server get switched when you send it to a client, so that it makes sense in terms of the word local and remote. A little bit more does happen, because if you set an autonomous proxy, this basically means that the client who actually created this object will get an autonomous proxy instance, but all the other clients will get a simulated proxy, so it gets downgraded. And that's useful for basically player controls, and we'll explain that later as well. So we're going to set this to a simulated proxy, because for now we don't need any of the advanced features. And we're not going to actually use this RPC call, so we can just demonstrate things this way. Great, so that's what basically the simulated system does, and that's what remote roles serve to do. Now, we've also got this arguments panel, and arguments are the data that we send across with the RPC call. By default, these won't be selected, and these are populated from the logic brick properties that you have. So if I create a new property, you'll see we get one here. And if I delete a property, you'll see that I deleted it there as necessary. If I rename a property, you'll notice that the checkbox delete is unchecked. I'll show you again. And the reason for that is there's no actual way to detect if we've renamed it or deleted it in the BPI API. So that's just a little nitpick that we have to deal with. Nitpick even that we have to deal with. So yeah, you can enable these arguments, and that means that these arguments will be copied over the network when we send the RPC call. So before we move on, it's important to remember that RPC calls are kind of special. They're typically sent from the server to the client. The reason for this is that only a network object that belongs to the client in question can send from the client to the server. Likewise, when a server executes an RPC call on an object, it sends to the connection that owns, or the client that owns that object. So this kind of a notion of ownership is really important, and the general idea that this brings about is that RPC calls do not broadcast to all clients. They only send to one client or one server. So we can later on look at who those particular clients and servers actually are, or server singular. So that's the RPC system. Let's ignore that for now. Now, network state is quite important as well. It's basically to enable you to switch the logic out depending on whether this is running on a client or a server. So what you basically do is select your network state, and if you then enable the layers in this layer selection, they will be set as active when the object is spawned, only for this particular net mode. So if we selected client now, you'll see that we only enable state 1. But if we are a server, we enable state 2 and a few other states as well. So this means you can run different logic bricks depending on which kind of network you're on. And that's quite important too. You can click this refresh button to basically save this as part of the configuration, or something along those lines. Anyway, it's been a while. Please allow me to correct myself. What you can do is, if you set the states as visible in the logic brick user interface, clicking this button will set them as the states that belong to this network mode. So basically this is a way of setting it from the Blender UI into my network UI quite quickly. So that's all that really network states have. Now, simulated states is also another thing. Recall earlier that we talked about RPC calls as being denied on clients which are not set to a simulated flag if they are a simulated proxy. The same thing can apply to states, because sometimes you want to run logic on the owning client but not on any of the clients, even though they're both clients. So what this basically means is that when the network state is attempting to be set on the client, if you're a simulated proxy, then none of the states I've selected would actually be set. And so to ensure that they actually are set, what we have to do is enable it as a simulated state. And that will make sure that the state is set. So that describes the state system. Now, replicated attributes are quite similar to the RPC call attributes. Basically, they have a name, and they have two other important features. There is this information icon, and there's also this speaker icon. Now, speaker basically refers to whether we actually want to replicate this attribute or not. And if you enable an attribute for replication, you'll notice that you can no longer select it in the arguments list for an RPC call. The reason for this is that I imagine it would probably cause some confusion otherwise. It would be possible to send something to the server and then it comes straight back. And that may cause problems. So if you wanted to do that, you'd have to create an intermediary property. So that's fine. Now, the information icon is basically serving to trigger a message when this variable is updated on the client. So replicated attributes basically work by sending the data from the server to the client. That's the only direction they travel in. They're sent whenever they change, according to the network update frequency, unlike RPC calls, which you have to trigger manually. And sometimes it's useful to have a changed attribute to trigger something. So I mentioned earlier that RPC calls do not broadcast, but you can trigger a form of broadcasting by basically changing a network attribute. So let's say you had an attribute called play death sound, and you said that was a boolean, and that was set to false by default. If you set it to true on the server, and all the clients and it was set as a replicated attribute on the server, and the clients had enabled the notification icon, then whenever this attribute was changed, you'd suddenly get a message on the clients saying something like, you've received a message for this attribute. And that means they could all play that sound, and you only have to have one attribute to do that. So that's quite a useful feature. And you'll receive different messages, the actual subjects themselves change, for different attribute names. And that basically describes replicated attributes. Now, templates are quite a very important part of the system, and they're generally designed to allow you to share network systems which aren't just written in logic bricks. So you could write code, and someone could write an add-on, or they could write some code and give you a template, and as a non-programmer you could still use that template provided that you it was designed to work with extension in this way. So basically what a template is, in its fundamental idea, is a module which contains some network template classes. So it's a Python module, is what a template basically is. And inside of that module, you can define network objects, which inherit from a special base class, if you're familiar with classes. Now, if you're not familiar with classes at this point, it would be best to skip ahead, or maybe even finish the video here. I will put some links in the description if I need to. So in this case, in my main loop module, which is actually a part of the network system, we have one template class called SCA_actor, and that's the base class for actors in the Blender game engine. In reality, you'd actually inherit from an actor class, but that doesn't have all of the logic required to run the Blender logic bricks with the network system. Now, inside of the template attributes panel, you'll see that we have some attributes, and I've basically made the UI code strip out underscores and make them into titles. So the actual variables themselves are not written in this manner. They are, for example, always relevant is written as always underscore relevant in all lowercase. But this makes it more aesthetically pleasing. And it gets the correct type for these variables, and you can set them. So it only works for primitives, basically. And the purpose of this is basically to enable you to configure things without having to write code yourself. So most of the time, a lot of these properties or attributes will be inherent to the class, and you won't always need to change them. So the definition name is basically the default name for definition files for objects, and we'll explain what that means in a minute. The other attributes are, for example, replicate simulated physics, which means that should we send the physics state to simulated objects, which means objects with a simulated proxy role, and most of the time you're going to want to do that. And also, always relevant means that basically, should this object always be considered to be relevant, and it's part of a relevant system, which is completely different to this as well. So there's all of that jazz, and it's basically to enable you to do more stuff. And if you click on Game System for Entities, these are the default game classes that we have. So you can create weapon attachments, projectiles, pawn, nav mesh, and so on, and all of these things are quite useful. There'd be one or two places where you shouldn't use certain templates because they won't work in the correct fashion, but I will work on that in due course. So that's the entirety of the network system, and all we need to do now is look at basically how this data is configured, because that's quite important if you're creating your own files. You'll notice all these folders are being spawned. So let me open. Inside of the directory where this Blender file is stored, we have this network data folder. And what this has is basically folders which are named according to the objects that they describe. In this case, cube is an object in one of my scenes, and so is dispatcher, which is the current object we're editing in the Blender instance. And inside of these we have these definition files. So the definition file, there's two different types. One is used by the system that runs for the Blender game engine only, and that's the one that basically deals with logic bricks. Now another one, which is the definition.cfg, is used generically by the game system to load stuff in the BGE. So the important thing here is that in the Blender game engine you don't need this add-on to work in the Blender game engine, but this add-on gives you the visual interface. That's why we have two files. So the actor.definition is basically used to export all of the data required for this network object to be set up correctly. So it has things like RPC calls here, and it defines an RPC called function, and it tells you all the properties for it. It has all of the simulated states, which unfortunately is quite large. And it also has some templates that it uses, and other things along those lines. So all of your network objects have these kind of folders around. Now if you look at cube, for example, let's actually go and edit the actor definition. It's a lot bigger. It's got quite a few parameters and so on. And in this next video we're going to look at how to create a demo game. So this is just an important note. Now the last thing we have in the network data folder is this main.definition, and this is actually the export of the scene configuration data. And this is used to configure the game when we start it, of course. Now this is one part of the system I will probably change, because you'll notice that if we only have one file to describe the network configuration of the blend file, if you tried to have a server and a client share the same network data folder, it would overwrite the main.definition. So to avoid that, I will actually have to make this probably local to the blend file or something along those lines. But ignore that for now. As I said, the system is a work in progress. So in the next video, which will be coming out soon, I'm going to describe how to create a network game.